This is the 1440 or 1428 session Cloud Application Platform Roadmap. And we're going to talk about Cloud Application Platform. I am Ron Noonan. I'm one of the product managers on Cloud Application Platform. Troy Topnick is the other product manager that works on this product. He's quite focused on it, and he's at and doing presentations today and this week at the Cloud Foundry Summit in Philadelphia. So I get to do this without Troy, which is kind of a sad day. But Jeff is in here for a little while, and Jeff is actually the Director of Engineering for Cloud Application Platform and Container as a Service Platform. So all of this is under Jeff. So when you actually have a detailed question, ask it up front, and we can get Jeff to offer an answer. So what are we going to talk about? We're going to go through a mission statement, what we really want to do with this product, where we want to take it, the roadmap itself, what we're actually planning this year, this new release this month, what's happening this summer, which is pretty exciting, and then what we're going to be working on throughout the rest of the year in 2020. The key features, we'll drill into some of them, and then the life cycle, how it's changed and what we're doing this year for the life cycle and managing Cloud Application Platform, and then a new pricing model. And really, the important stuff is the roadmap and the key features. We'll focus on that. If we get to the other stuff, or if you have questions, I threw those slides in there so that you would have more detail on it and you could download it and look at it. We may cover it in here. It doesn't really matter if we don't or we miss it. So everyone's seen this slide if you've gone to any of the sessions. Cloud Application Platform is part of the application delivery focus at SUSE, where we are helping people build out and deliver and manage and deploy to build, manage, run, operate container-based applications and modern cloud-native style applications. And Cloud Application Platform is specifically targeted at that market. If I look at the mission statement, I want to read it. Supply a turnkey container application platform that manages applications through their life cycle from code to deployment, managing dependencies, application health, and upkeep. We want to do that for the Kubernetes environment. We take all of the facilities of what you're going to see as Cloud Foundry and allow you to take the benefits and the approach and the management and the application view of Cloud Foundry. A developer could type something very simple. It's a nice little architecture diagram. Type something very simple like CF push, and it will actually do all of the work until you have a running container application deployed in a Kubernetes environment. So the key focus that we talk about and what we're really working on is focused on Kubernetes, but it's also a Cloud Foundry application set. So we want to be able to provide Kubernetes, not just the container operational platform, but the ability for you to actually look at from an application viewpoint, work with your application sets, and have the infrastructure of Cloud Application Platform manage everything that actually happens in Kubernetes for you. So you work with your code, you work with your application, you tell it what you want it to do, it will actually figure out everything to do, install it, and make it happen. Cloud Foundry applications, if they actually are native Cloud Foundry applications that are in the traditional old VM style of Cloud Foundry, this product set can actually take those applications unmodified and then run them, deploy them, and put them into a Kubernetes environment and let you run them in a Kubernetes environment, even though they were built for the old Cloud Foundry environment. So I'm not going to read all of those, but that's the long list of things. And the real key points here is that we are bringing the Cloud Foundry workflow to Kubernetes. So here's the roadmap. We'll go through it. So we released 1.0 sometime in 2018, beginning of last year. And then we've done roughly quarterly updates to the schedule. You notice that it's March right now, or April. It's April, and we're just doing 1.4. So we haven't quite done quarterly. But we are releasing point releases roughly every quarter. And then we have gone through 1.3, that is out. The next release that's coming out, and that's coming out this month, is the 1.4 release. And that's where we'll see some new features like the support for Google's Kubernetes, or GKE, joining the ability that we have on Azure and AWS to be able to run it on AKS with Azure and EKS on AWS. We're adding the ability to run it on GKE, and we'll talk a little bit more about that. We're also adding a policy and a way to bring your own Kubernetes so that you can run this application platform and install it and take advantage of this enhanced workflow and application viewpoint in any Kubernetes environment within the certain restrictions that we can talk to. We're also going to be adding a bunch of Cloud Foundry updates that are coming from upstream. They'll be incorporated and pulled in. And then the 2019 certification will happen for Cloud Foundry. And then we'll talk about the new ability to do DRBD, which is a persistent store technology. And then the Irene tech preview. And I'm going to go into Irene in a little detail and talk about what that is. Because in 2.0, which is coming out this summer, it's going to be a relatively rapid change from 1.4 to 2.0. Right, Jeff? That's right. So we're going to go from a rapid changeover and change that tech preview of Irene and what it does, and we'll talk again about that. We're going to change that into a full production environment this summer, and that is a major architectural change, and it's very interesting in the world of Kubernetes. So we'll talk about that, what it is, and then some of the other things that are happening in 2.0 this summer, pretty major capabilities. And then we'll look ahead at some of the other things that are coming in the rest of 2019 and 2020. And Jeff, actually, I want to point this out. So Jeff is, again, he's the Director of Engineering. He's in here only for the first half of this session. If you have any questions that you think would be interesting to an engineering director, ask them in the first half. Okay, so support for Google GKE. This is new, but what's new about it isn't that it works there. The product has always worked in GKE. It always works in AKS. It always works in EKS. What's changed and what we're bringing to the table is that we are putting it in our QA test platform, and we are documenting all of the steps required to make it work. So it becomes a documented and tested infrastructure component of the build systems. And that's what's really changing here. But we have already worked on it. We already do work with GKE, and if you have, you want to use it now, even before the release at the end of the month, you can actually put it up there and stand it up, and it will work. Again, this is joining AKS and EKS as already previously documented and supported platforms. So the policy for bring your own Kubernetes is actually new, and this is something that we've been doing and are talking about for a while. The world of Kubernetes, and I don't know in here how many different types of Kubernetes are represented. Tom, you were talking about container. Does your company have a specific Kubernetes platform it uses? Yeah, so there's a lot of them out there to choose from. SUSE supports and documents support for SUSE CAS platform, our own Kubernetes platform, and then the three public cloud environments we talked about, AKS, EKS, and GKE. But if you have a different one, and we've been approached now with lots and lots of different requests for supporting Kubernetes, we are going to say, yes, we will do this now. We will support it on whatever Kubernetes platform you want to run it on with a certain set of caveats. And the caveats are really, in a rough way, if any problem you have can be recreated on one of our documented platforms, we will address the issue. If we can't address it, if we can't recreate that problem on one of our documented platforms, we will support you on a best effort basis. So that's the way we're going to take it to the market. We'll see how it works. We've already had a few other CSPs ask for the ability to work with, for instance, Huawei Kubernetes. Another thing that's happening in this release is the Cloud Foundry certification. If you would like to take a first of all, Cloud Foundry is an upstream project. It's very large. I assume most people in here know what Cloud Foundry is. This is a Cloud Foundry distribution to the point where it is actually certified. We're certified in 2018. We're certifying in 2019. And even when we do our architectural changes, we will maintain the certification. And the architectural changes are large. But with those changes, we will still offer the certification. So you can take an application, and the certification is designed to state, if you have an application that runs in a Cloud Foundry distribution, and you want to move it to a different Cloud Foundry distribution, it can do that, and it should run just the same. And this is actually pretty valuable from a SUSE Cloud Application Platform perspective. Our Cloud Foundry is different than other Cloud Foundries, but not from running the code. When you take it from a standard Cloud Foundry environment, and I'm going to show you a couple pictures of this in a minute, you're going to be in a VM environment. And when you move it over to SUSE Cloud Application Platform, you're going to be moving from a VM environment to a container environment. So your ability to run the same application will all of a sudden take a lot fewer resources, and the footprint will be much, much smaller, because every VM will be replaced with the equivalent container. So the Stratos console is something that we are, and this is kind of a bridge. We're going to be doing updates to the Stratos console. And I know that there's a Stratos session that's happening right now that's talking about some of these new things that are happening, which is unfortunate they're at the same time. But that's going to have new additions in the 1.4 and in the 2.0 environment. And I encourage you on Thursday at this same time slot to go over and look at the Stratos environment, because this is a component that SUSE has built. We've put it upstream. It's available upstream. It's part of the Cloud Foundry Foundation now. But we lead that project, and it's a very rich management environment and web application, really, for looking into and managing the applications in the Cloud Application Platform. It shows you all of the Cloud Foundry specific activities, and it's growing and showing you more and more of the Kubernetes underlying infrastructure also. So Jeff, I don't know if you wanted to talk or say anything about that, since it's really one of our gems.
Yeah, it's all,
I didn't prep them for this.
It's great UI for really getting a great management level view of everything that's going on from your infrastructure and from Kubernetes all the way up through to application management.
Yeah.
So, and we are continuing to build out that feature.
And it lets you see multiple endpoints. So from, say I have an environment installed on CAS platform in my data center on-prem, and I want to install some of my workloads up on EKS, or I want to install a different set of workloads up on AKS or in GKE. From the same management console, I can actually say, I want this workload to go to that spot, this workload to go up to that cluster, and I can pick and choose the various endpoints I want it to install the workloads in, and I can manage it all from that single environment. So it actually is a really useful tool for not just managing a single environment, but for managing it in a multi-cloud hybrid kind of implementation.
What would be things that SUSE Manager can do that Stratos can't?
Oh, SUSE Manager, Stratos is really not anything like SUSE Manager. There are some places where they overlap a little bit, I think, in image management, possibly, authentication. But SUSE Manager is really designed to help you deploy and do patch management to things like SLES. Stratos doesn't have any of that concept. Stratos is focused on containers and container applications. It works with Cloud Application Platform, which is not a set of RPMs, but only a set of images. So it's actually the first product at SUSE that's distributed as a set of images and not RPMs. Stratos is built to look into that. It helps manage those components, but then it also looks into that, and it's tailored to actually look inside of Cloud Application Platform and tell you, well, this application's running, it's running on these resources, it's got this many instances running, and it's very focused on that. So they're side by side, really. They're not competing that much. Does that?
Level, how it's built, what patch level it's at, and the various pieces
that
might build out.
That's a good way to look at it. From here down.
The Stratos
here up.
view is from the container and application platforms on up.
Yeah.
So it's looking at things as clusters and thinking of them as pods or applications.
Yes.
And the metrics that come out of them and application management, whereas SUSE Manager is thinking of things at the OS and core as well.
Yeah, we could tie things together more, and we probably will over time. But right now, that's a really good way to segregate it, and I should have done that on that picture.
Thanks.
So SES and DRDB. Today, Cloud Application Platform, it helps you build cloud native or stateless applications and with all of the best practices. It allows you, when you build it this way, to scale up and add more resources to your applications. It also lets you scale out. So as it requires more nodes, it will just add more nodes onto the application services that are running out of resources. And to be able to do that correctly, it has to make sure that all of the state that your application has is not managed in those nodes themselves, but managed externally. And so you need an environment to have persistent storage where it can actually manage the state it needs to know about. And we've, in the previous version, supported SUSE Enterprise Storage as a persistent store environment where you can hook that up with Cloud Application Platform, and we've provided you an entitlement to use it. In this release, we're going to start supporting DRBD also, because there's been a lot of requests to have very small, lightweight capabilities to do persistent storage, maybe a couple of nodes, all I need for my Cloud Application Platform set of applications. DRBD fulfills on that. We will provide that and support it and provide you the SUSE HA entitlement to actually install it if that's what you desire to do so. Okay. So this is, now we're into 2.0, squarely in 2.0. This is what is coming in 1.4 as a tech preview and is the key architectural change in what is coming out this summer in version 2.0. And it's a Cloud Foundry project called Irene. It's not really sure what the name means, but it's had it for quite a while. Perfect. We know the gentleman that named it. He's a very nice guy. So what's really interesting about this is it makes Cloud Application Platform, right now, today, we can install and manage applications that are ultimately deployed into a Kubernetes cluster and run there. But it uses a lot of infrastructure from Cloud Foundry to help do that inside of the Kubernetes cluster. With Irene, a lot of that Cloud Foundry infrastructure is being removed, and you can actually have Kubernetes natively take over those functions. So really what's happening is the orchestration capability of Kubernetes is now orchestrating the workloads natively. The images that are built are deployed directly into Kubernetes environments. And I'll just show you a couple of pictures here. So today when I install Cloud Application Platform, it installs a large set of containers. And the actual infrastructure of our product, the application itself, Cloud Application Platform, the broker, UAA, lots of the various functions, they are containerized and they install into a Kubernetes cluster as a set of containers. We have a Helm install. It's very simple. You put it in. It installs to the Kubernetes environment. And then you can provision applications and tell it to run applications. When it runs applications, it spins up Kubernetes containers to actually deploy the workloads in. And then all of these workloads that those gray boxes represent and the blue sleeve boxes represent are actually Cloud Foundry specific garden containers that are orchestrated by Diego and deployed inside of the Kubernetes environment. So there's really an orchestration within an orchestration in this implementation. The end result is you have your application orchestrated and running inside of Kubernetes, and it's very, very efficient because in the traditional Cloud Foundry, all of these green boxes are VMs, and in the Cloud Application Platform, all of these green boxes are containers, so that the resource utilization goes down tremendously with our 1.0 architecture. But in 2.0, what we are doing is we are deploying all of those gray boxes and blue boxes as basically native Kubernetes workloads. There is no longer a Diego orchestration component that is needed to manage those workloads, and they are no longer running in garden containers. They are just running as native Kubernetes workloads and native Kubernetes containers. So the same workflow, the developer uses the same commands, the developer application is unchanged, but what actually happens inside of the runtime and in the infrastructure becomes much more natively Kubernetes. Some people have asked, why did you do this? I mean, why do people care? The developer experience doesn't change. If I were a developer using Cloud Foundry or Cloud Application Platform, and I did this change, I would never know. I would never know that this was now running more natively in Kubernetes than it was yesterday or tomorrow. It wouldn't matter. But from an operator standpoint, and what I have to examine and how I manage things, this is a fundamental difference. This simplifies the entire environment and the stack to be much more natively Kubernetes, which is what people have been asking for. So that's a major architectural change. It's actually pretty cool. This is where people are supposed to stand up and cheer. This is actually really a highly asked for component. So this CF containerization, CF operator, SUSE has led the effort to build out the containerization of Cloud Foundry and bring, so Cloud Application Platform the whole containerized approach and building it as a Kubernetes application and building a lot of this Kubernetes functionality as at the forefront of what we do, and making sure that what we are doing is not to make, well, what we are doing is to make Kubernetes application management better and surround the developers with more tooling to help them do it more easily. That's our goal. We led these projects and then pushed these projects upstream. And so these projects have been in our product for a long time, but they're upstream as incubator projects, and they're going to be turned around as production capable components, and we are going to be taking now the production capable capabilities that are coming from upstream that are being led by us in a lot of places, and building them into the product set. And you'll see that in 2.0. And you'll see some immediate changes in things that you can do in the infrastructure. Zero downtime when you do upgrades, rollbacks, canary deployments. It sounds a little sacrificial. And then a lot more granular capabilities on configuration. So there will be tangible changes to this, but a lot of this has been driven by just the overall community coming together and endorsing the architecture that we pushed up there. The other thing that's up there, this has been a very highly requested capability in the platform, which is what we are pushing in as CF Abacus, which is a project up on the Cloud Foundry Foundation. That's an add-on to any Cloud Foundry environment. We are going to be incorporating this as a containerized component to be able to run and offer with Cloud Application Platform. And what it allows is gives you all of the data and logging information and understanding of what's being used and what resources are being used by what users, organizations, and the like. And the reason is people want to be able to do build backs. They want to be able to bill internally. They want to be able to bill externally. We have people asking to use this as an infrastructure, as a service for CSP environments. We have people wanting to do it internally, but service other departments. CF Abacus, when we put this infrastructure in place into the product in 2.0, will give you all of the data you need to be able to compile reports and actually do build backs. And this is another aspect that's happening. We will see if it happens this summer or if it happens this fall, but this is, I put it up here as one-click install for the cloud service provider platforms. We have, again, the 3 targeted cloud service providers that we support, AKS, EKS, GKE. We are going to build out, as part of the standard infrastructure, completely finished templates that will be running on those platforms, supported by engineering, Cloud Application Platform engineering, and pushed up into those environments so that you can just go up to Azure or AWS or Google's GKE, and you can just say, I want to run this. Say start it, and it will build you an HA production-ready environment, fully integrated into the environment, with the service brokers hooked up and everything. And then it'll provide you the documentation so that you can go change it. So we will actually, this is, in a way, not really changing the product. It's just simplifying everything that you have to do in a public cloud environment, so that, like what the public cloud promise is, things need to be easy. Make this easy. It's a simple install. Every rev of the product will get updated, and it will be pushed up into those target platforms. So where are we? I'm fast. Istio is another component of the environment that we are going to be doing. So this is a service mesh implementation, Istio and Envoy. We will be implementing an aspect of Istio with Cloud Application Platform. That will provide you the ability to have policy management and a number of other things and actually managing and understanding the services that are deployed throughout the environment. I don't know if people are familiar with this. Istio is a project that's more or less been pushed out by Google, but it's open and it's pretty popular, and we will be implementing it in the environment, and you'll be able to use it throughout the environment, throughout the deployments, regardless of where it's installed. I guess that's enough for that. Serverless. This is actually an interesting thing. So serverless is very popular. You hear it serverless, you hear functions as a service. I wrote up a couple of bullets up here, but I'll describe a few of the use cases that we've seen come across that we think are very interesting that we want to solve. Yeah, I thought that was funny. I just put it up there. the economic impact on serverless. So the functions as a service, this really is popular up on the CSP environment. So when you look at Cloud Application Platform, I've been asked, well, what's the use case? Why do you want to be able to do that on-prem or in the cloud or in different places? And I've really had two aspects come back. One is we have a lot of front-side tooling to help you build out and add to the Kubernetes environment what are essentially platform as a service capabilities to a Kubernetes platform. So the platform as a service gives you lots of things and manages lots of things for you that Kubernetes doesn't do. And it's not that it can't do it. It doesn't do it on purpose. It lets you control that stuff. And by layering this into the Kubernetes environment, then you get a lot of that richness on the Kubernetes environment. The same thing happens with function as a service. People have been asking, can I have a controlled build environment so that I can build out my functions and have them deployed and not have to manage everything manually? And so plugging that into the same workflow and having you to say, well, this is something I want to behave as part of a platform style application, or this is something I want to deploy as a set of functions, you should be able to do. The other thing, and this was interesting, this is more of kind of a 2.0 requirement that we started hearing from IT shops that came along. People that had started working with functions, like, this is great, talking to a very large stock brokerage data analysis company. It's like, oh, we love functions as a service. I can just go to a developer, say, I need this query, just write this query. The person doesn't have to know anything about how it's being used. It's a standalone function. They can just knock it out, hand it over, and we can put it somewhere and it runs. The problem we've had is that once it's out there somewhere running and we update another application that uses it as a dependency, we forget about it. We forget these things are there. We forget the functions. We forget which functions are being used by which applications. We need a better holistic view so that when we deploy things, we know what belongs to what. And having that ability to control that as part of the deployment process and then an understanding and a context of what those functions belong to is useful. So the one thing I haven't put up on this slide is which framework we're actually going to be pushing in. And we've been talking about Knative, OpenFOSS, different things. That's actually an engineering discussion right now that's ongoing. That is yet to be determined. So we will pick one of them somewhere and implement this in this environment. But the basic use case, the things we want to solve, won't change regardless of which implementation we pick. For that matter, talking to my friends over at Microsoft, they said, well, you can use our functions as a service. Or AWS said, oh, you can use our Lambda. The point is we want to solve the issues around using functions as a service and serverless. And then which framework we plug into or where we push things is more of a question. So Jeff's about to leave. Did you have a comment, or are you just trying to figure out how to leave? Okay. All right. So the Cloud Application Platform capabilities are actually going to extend quite a bit in the next year and a half, 2 years, into different areas. You're fine. We are going to be providing a container interface. Right now it's looking like Portis, but it doesn't really matter if it stays Portis. We are going to be also expanding into the CI/CD environment and supplying more of the tool chains in front of Cloud Foundry capabilities that are provided in Cloud Application Platform. Today, when I type CF push, I can point it at my code. It'll figure out what my code is. It can be Java, Ruby, Python, whatever. It'll figure out what code it is. It'll compile it. It'll package up and do that. It uses this concept and technology called build packs. And these build packs will then analyze the code, figure out what to do, set up the environment, build out the networking infrastructure, set up the DNS. It'll do all of the work that you have to do manually to roll out a cluster and an application into a cluster. It'll do all of that from that single command. But it doesn't do the stuff in front of that. It doesn't help you code that application in Jenkins and then move it through that process, or it doesn't help you in certain other ways that some of these CI/CD systems like Jenkins or Concourse or aspects of GitLab help you do, or Microsoft Draft for that matter. There are different things that you can do We will be adding some of the services to let you plug into those environments so that you have more of that front-side developer story that plugs into this automated tool chain. We also are looking at the online IDEs so that we can plug this all the way into an IDE environment, so that like Eclipse Shay, and plug that into an online IDE. Someone wants to code in that. If they don't have to. But if they want to and they want to work in this environment and have it plugged through the automation, through the CI/CD systems, and all the way through the pipelines, that will be possible too. And again, so the certificate management, that's always going to be improving because certificates are complicated and we are touching lots and lots of things. So certificates are important, and that management interface is going to grow and get more robust. But certificate management today is there. The interface is for people that know certificates. And then we will be looking at providing one of the Git interfaces or Git sets of Git capabilities, whether it's from GitLab or Gitty or one of the others. So that's where we're taking the product outside of just the core roots of it in the Kubernetes environment and Cloud Foundry environment. So we'll be extending it more into the developer experience. So I'm going to stop here and just say, are there questions about this? Understanding the roadmap, where we're taking the product, why we're taking it? So, I mean, Tom, you wanted to know what the product was, and I'm not sure the roadmap overview tells you that entirely.
I'm getting a good idea.
Okay. So, well, I thought I would jump a little bit now and then talk about some changes we made that are coming out in the 1.4 release and how we're managing the life cycles, and then also how we've changed the pricing model this year, or this last release, and that is very different than all of the other SUSE products and different than this was last year. So today what we're doing in our life cycle is we support the current version and one back. But what that means, because it's not that straightforward, of course, is that right now I'm on 1.3. I'm about to ship 1.4, which I didn't have when I made this slide, and it was a lot of work to change it, so I left it like this. But so 1.3, say, is the current version. When 2.0 comes out, we will support 2.0 and the last version, one back. When 2.1 comes out, we will support 2.1 and the last major version. But when we say the last major version, we will support the most recent service pack of the last major version. Always the current release and current service pack, and then the last major service pack of the last point release. And that is the life cycle. Does that make sense? Because I've showed this slide to other people that work for SUSE, and they go, I don't know what I'm looking at. But it's fairly straightforward. Okay, I'll trust that that works. And then here's the new packaging and pricing model. We changed to what is now an on-prem and CSP-friendly pricing system, so that you can basically use the same pricing and usage model, whether it's on-prem and workloads are running on-prem or whether they're running in the cloud. And that is it's a core-based system on-prem or a vCore or vCPU-based system in the cloud. And there's an easy ratio. The vCore is essentially 2 vCores per core with the hyper-threading enabled. So I have a full version of the product with all of the entitlements like SES and DRBD and CASP. I can run it for $1,660 a core or 2 vCores, and that's the price. So if I take it on-prem, I can count it on the physical servers. I can see how many cores I want to run it across. I move a workload into the cloud. I can see all of the instance types and AKS and EKS. They will report how many vCPUs you're using so that you can actually translate it directly on those platforms also. So it's a very simple model that works across the boundaries. And you can have the ability to buy it. So if I run with these workloads, say the way it actually works is it only charges you for the vCPUs or the cores that are running the workloads themselves or the components of Cloud Foundry. So if I've got admin nodes running in my environment that are separate systems and separate nodes than the compute nodes, I don't have to pay for them. The only thing we're counting are the vCores or cores that are supporting the actual compute nodes and the infrastructure itself for Cloud Application Platform. And that's the version right there. That's an example of running it on-prem with all of the entitlements, what it would cost and at retail pricing. Here's the equivalent version, say, running in the public cloud on one of the managed service, managed Kubernetes environments. The entitlements are no longer there. The worker nodes no longer show. The worker nodes, you deploy it, it looks the same in the cluster. You're only paying for those components, and then you can actually plug into the actual services on the public cloud for those environments. And you're looking at it from a vCore standpoint instead of a core standpoint. And that's really the change we've made this year and how this product's brought to market. And actually curious, does that make sense? Try to make these slides somewhat intuitive, but there's a lot of information on them. And at that, I go back to the roadmap, which is, so where are the areas that are interesting that you might have questions on? Because that was the content I wanted to bring up and cover, and then leave some time in case there were questions about how we're doing Irene or how we're doing some of the support options, if there are any. So, and it doesn't sound like there's too many questions.
I don't know if there's something else we could learn here, in another session, but how do training and education and professional services from SUSE complement this? Are there plans to do that, or do you have to get that somewhere else?
So there's two ways to do that. We have a small consulting force that's training up on this and creating training content for this. But we also use them with our partner network. So we are more of a partner-first company than a consulting company. And our goal is to have enough expertise and train the trainer capabilities to make sure that when you do something and you work with a partner, that we make sure it's successful. And whether we provide this as a managed service offering, say on Azure, which is under discussion, things like that could happen. Even that could happen directly from us or through a partner. But our goal is to make sure that and there are several partners that do this today, so global SIs and several regional partners that this is a very popular product obviously with management environments or consulting environments and training environments, because it's the kind of thing that needs it. But we do have a staff that is expert in it to do that. And answer your question?
Yes.
Okay. Question?
I'm an employee, so
Yes.
yeah, we are trying to sell it in Latin America. I'm from Argentina. It's not easy because in Latin America the companies are growing, but not so fast, and it's complicated to adopt those technologies. But we can see it in our list price.
You can't see it. Well, that's a different conversation for this public session, but I can tell you it's not in your list price. It's in the private list price that we can help you with. So, and that goes to your question in an odd way. You wanted to know, how do we make sure, do we train and all of that? Well, we want to make sure all of the implementations are successful. And since this is a product that actually requires literal understanding of its implementation to be successful, we make sure that people that are part of a worldwide global go-to-market team are involved with every sale. And so when you ask for pricing, you have to get it from them so that they can help you. And that's the only reason it's like that. And because this is very important environment and making sure that these applications are successful. They're always mission critical. They're always HA in their implementations. And so that's why the approach is taken. Other questions?
And to confirm, just to confirm, the licensing model is per virtual CPU using in the CAP in this case.
Correct. Yes. That is correct. Virtual CPU or core. If that's it, thank you.